We have liftoff of the Titan Centaur carrying the first of two Voyager spacecraft to extend man's senses farther into the solar system than ever before.
Voyager 2 just turned back, and for the first time since its launch nearly half a century ago, the spacecraft behaved in a way no one had anticipated. It was subtle at first, an almost imperceptible deviation in its trajectory that ground controllers initially blamed on a calibration glitch. But the change persisted. Telemetry steadied into an unmistakable pattern, and the old probe adjusted its orientation with the slow dignity of something ancient, battered, and impossibly far from home. Then came the data stream. At first, it spilled out in fragments, the expected cosmic ray counts and magnetic field readings mixed with anomalies that no model could quite explain. Engineers watched as the probe's instruments registered pressures that should not exist, fluxes of energy that defied the known behaviors of interstellar space, and signatures of motion that hinted at forces that did not belong to the gentle emptiness between stars. Something had disturbed the quiet, and Voyager 2, wandering in the cosmic deep, had been the first to sense it. Before we start, smash the like and subscribe buttons for more updates. The vibration transmitted through its instruments was not a physical tremor, but a complex fluctuation in the interstellar medium, as though a distant event had sent a ripple across the galaxy's outer fabric. Such disturbances had theoretical precedent, usually linked to supernova shockwaves or massive stellar eruptions. But this particular pattern carried a structure too intricate to align with natural astrophysical events. It repeated in intervals, modulating in intensity before fading into a silence more profound than before. When analysts on Earth inverted the signal, enhanced it, and ran it through layers of pattern recognition, they found something astonishing. The fluctuations mirrored spatial ordering that resembled geometric sequencing, not unlike the mathematical pulses once imagined in hypothetical attempts at interstellar communication. Voyager 2 had not only detected an anomaly, it had detected an anomaly behaving as though it wanted to be noticed. From the moment this realization crystallized, the mission team experienced an extraordinary tension. Voyager 2 was not designed to interpret deliberate patterns, nor was it equipped to respond to them. Yet its ancient instruments had stumbled into a region where the structure of space itself appeared altered. The probe's plasma wave sensor registered sudden pockets of compression, as if invisible boundaries existed beyond the heliopause. These boundaries shifted like drifting membranes, reacting to the passage of cosmic dust and solar wind remnants. It was as though an unseen architecture lay scattered in the darkness, its edges brushing against Voyager's hull as it drifted forward. The probe, following its programming, reacted by altering course, pivoting slightly, and transmitting higher frequency scans. To many, the turn looked intentional, as if Voyager 2 were attempting to trace the outline of what it had encountered. Months of analysis revealed something even stranger. The fluctuation patterns Voyager detected extended far beyond its immediate vicinity, suggesting that the anomaly was not local, but part of a vast region stretching across a significant segment of interstellar space. This region did not behave like nebular matter or relic radiation. Instead, it shifted in ways reminiscent of dynamic systems with feedback, responding to environmental changes rather than passively existing. Every time a burst of cosmic rays approached the boundary of the anomaly, its structure warped slightly, absorbing the incoming particles before relaxing again. These motions repeated with eerie consistency until the anomaly's internal modulation intersected with Voyager's signal frequencies. At that point, patterns emerged that resembled harmonics, the sort produced when two oscillating systems interact. Voyager 2 was not merely observing the anomaly, it was participating in a complex, perhaps unavoidable exchange. As the patterns became clearer, a growing concern settled over the scientists monitoring the mission. The anomaly's behavior suggested coordination, yet there was no known natural system on such a scale capable of producing coordinated fluctuation. It was as though Voyager had brushed against the outer boundary of something that behaved like a network, a filament of some vast structure hidden in the emptiness between stars. Some proposed exotic explanations, remnants of dark matter, clusters behaving in ways not yet understood, interstellar shock structures shaped by forces too faint to detect from Earth, or even long-duration gravitational echoes from an ancient cosmic event. But none of these theories accounted for the sudden shift in Voyager's trajectory, nor the way the anomaly signals seemed to adjust in response to the probe's presence. If this network, structure, or boundary extended across interstellar space, it implied that the galaxy contained hidden frameworks influencing star systems across unimaginable distances. Perhaps these frameworks had always been there, subtly guiding cosmic processes, unnoticed until a tiny human-made object drifted into contact with one of their outer tendrils. The discovery challenged assumptions about the nature of space itself. The interstellar void, long considered an empty backdrop, might instead be threaded with interconnected regions capable of transmitting force, information, or something far stranger. For decades, astronomers had modeled the galaxy as a gravitational system, shaped by stars, gas, dust, and dark matter. Voyager 2 hinted at the possibility of additional layers woven through the cosmic fabric, layers that shifted and responded like sentient currents beneath still water. The implications for astrophysics alone were staggering. If the anomaly represented a previously unknown component of the interstellar medium, it could rewrite theories about star formation, cosmic evolution, and the distribution of energy in the galaxy. The data suggested that these structures might influence the movement of charged particles, altering the propagation of cosmic rays and potentially shaping the evolution of planetary environments. Earth had always been shielded by its magnetosphere and the Sun's protective heliosphere, but beyond that barrier lay a realm that had never been directly sampled until Voyager crossed it. Now the probe's readings raised questions about whether similar anomalies existed in other star systems, subtly shaping the conditions for habitability, or perhaps even playing a role in the emergence of life. Yet the scientific revelations quickly became overshadowed by a deeper, unsettling possibility. As investigators mapped the anomaly's modulation patterns, they realized that the fluctuations repeated in recursive sequences, folding back on themselves in ways that suggested intentional encoding. This pattern was not communication in any traditional sense. It did not contain symbols or linguistic markers. Instead, it resembled a system designed to alter its surrounding environment through oscillation, as though it were meant to create resonance with something passing through it. Voyager 2's instruments, primitive by modern standards, reacted strongly to these oscillations, indicating that the probe had entered a region where the boundary between physical interaction and information exchange blurred. If the anomaly acted as both structure and signal, it suggested that whatever created it possessed a profound understanding of the underlying mechanics of space. The warning lay in the nature of this interaction. The anomaly's structure changed more rapidly as Voyager moved through it, as though adjusting to the probe's presence. Simulations showed that if a larger object, such as a spacecraft or asteroid, were to pass through the region at high speed, the oscillations could amplify unpredictably. The result could be catastrophic: distortions in local magnetic fields, fragmentation of particles, or dangerous energy concentrations. Voyager, tiny and slow, had passed through safely, but anything else, including future probes or crewed missions, might not be so fortunate. The region was not hostile by intent, at least as far as anyone could tell, but it behaved like a dynamic system that reacted strongly to disturbances. Its existence meant that humanity could no longer assume that interstellar space was a neutral environment. The team comparing Voyager's recent data with decades of archived readings found a subtle but undeniable trend. The anomaly was expanding, not quickly, not catastrophically, but steadily, like a tide slowly rising across the galaxy. Its boundaries shifted outward by fractions of astronomical units each year, suggesting that it was not static, but in a state of growth or transformation. The implications were profound. If the anomaly continued its expansion, unchecked, it could eventually intersect with the heliosphere. What Voyager had encountered far beyond the Sun's influence might someday reach the outer edges of the solar system itself. The ripple patterns hinted at interactions with cosmic forces on a massive scale, possibly tied to cycles in the galactic core, or reactions to unseen phenomena beyond human detection. What unsettled researchers most was the realization that the anomaly did not appear randomly distributed. Its orientation suggested that it aligned with large-scale galactic structures, such as spiral arms and dark matter filaments. It followed a pattern as though guided by underlying gravitational or energetic pathways. If this alignment continued, Earth's region of the galaxy would eventually fall within its trajectory. The anomaly was not approaching deliberately. It was simply behaving according to processes older and larger than any living species. Processes that had shaped the galaxy long before humanity evolved and would continue long after humanity was gone. But regardless of intent, the consequence remained the same. Earth would need to understand the anomaly before it arrived. This was the warning embedded in Voyager's final transmissions. The probe had detected a phenomenon that humanity could neither ignore nor fully comprehend. As the data accumulated and the global scientific community analyzed it, a picture emerged of a galaxy far more active and structured than anyone had imagined. The discovery that interstellar space could contain dynamic, evolving regions capable of interacting with matter raised urgent questions about the long-term stability of planetary systems. If such regions could shift or expand, they might influence stellar winds, cosmic radiation levels, and even the integrity of magnetospheres. These effects could ripple inward, impacting climates, biospheres, and civilizations. The warning was not apocalyptic, but sobering. Voyager 2 had shown that humanity inhabited a small, fragile sanctuary within a much larger cosmic environment. Life on Earth depended not only on the sun, but on the complex balance of forces beyond it. The heliosphere acted as a shield, but that shield existed within a galaxy filled with phenomena that could reshape entire systems over millions of years. Voyager's encounter suggested that these processes were not static but dynamic, and some might be accelerating. The expansion of the anomaly, though slow, implied that the interstellar environment was undergoing long-term transformation. Understanding this transformation was essential for predicting the future conditions of the solar system. The mission team debated the possibility that other civilizations, if they existed, might have encountered similar anomalies. If so, perhaps they had developed methods for navigating or mitigating the effects. The galaxy could contain countless regions where such structures intersected with inhabited systems, influencing technological or biological evolution. Voyager's discovery could be the first step in recognizing a universal cosmic cycle shaped by forces humanity had only begun to detect. Some speculated that the anomaly might represent a relic of ancient processes, remnants of events predating the formation of the Sun. Others proposed that it could be the early stage of a larger transformation the galaxy undergoes periodically. Without historical data, there was no way to determine whether the anomaly was new or simply newly observed. What made the situation urgent was not the threat of immediate danger, but the scale of unknowns. Humanity had reached a point where its scientific curiosity extended beyond its solar system, yet its physical capabilities remained bound to Earth. Voyager 2, still drifting onward, served as a bridge between known and unknown realms. Its small body, barely a speck in the vast cosmic dark, had detected something that reshaped humanity's understanding of its place in the galaxy. The old probe had unexpectedly become a sentinel, watching from the frontier of interstellar space and transmitting warnings from a domain where natural laws behaved with unfamiliar nuance. The warning also held a more philosophical weight. Voyager's discovery confronted humanity with the realization that it was not the master of its cosmic environment. It lived within a dynamic, evolving galaxy whose deeper mechanisms remained hidden. The comforting idea of a stable cosmos gave way to a more complex vision of a universe filled with shifting structures, ancient processes, and forces that could alter the fate of entire systems. Earth's long-term survival depended not only on managing its own technological and environmental challenges, but on understanding the broader galactic context in which it existed. Despite the uncertainty, the data from Voyager 2 inspired a surge of investigation across multiple disciplines. Astrophysicists developed new models to interpret the anomaly's behavior. while particle physicists explored the possibility that unknown forces or fields might account for its patterns. Cosmologists revisited assumptions about the fabric of space, wondering whether the anomaly represented a hidden property of the universe that became apparent only under specific conditions. Engineers considered whether future probes might be equipped with instruments designed to safely navigate or study such regions. Even cultural scholars joined the conversation, examining how this discovery might reshape humanity's perception of itself and its relationship to the cosmos. Voyager 2, once a symbol of exploration and curiosity, had become a symbol of vigilance. It had revealed that the galaxy still held mysteries capable of influencing humanity's destiny. The probe's unexpected turn, its encounter with structured fluctuations, and the revelation of a slowly expanding anomaly all converged into a single powerful message. The universe was not finished shaping the environment in which civilizations arose. Humanity was living in a transitional moment, one where knowledge could mean the difference between resilience and vulnerability. The implications reached far beyond astronomy. If the anomaly affected cosmic ray propagation, it could alter radiation exposure on future interstellar missions. If it interacted with magnetospheres, it could influence planetary climates or atmospheric stability. If it represented a form of structured energy, it might one day provide insight into technologies far beyond current capabilities. Understanding it was not simply an academic pursuit, it was essential for any long-term vision of human survival and exploration. Voyager 2 continued drifting, its signal weakening with distance, yet each transmission carried data that deepened humanity's understanding of the anomaly and its vast scale. The probe's journey was far from over, even as its power dwindled. It remained humanity's lone ambassador to a region where the familiar rules of space bent into astonishing new patterns. The world watched as the data arrived, each packet a reminder that the frontier was larger, stranger, and more dynamic than imagined. The warning became clear. The galaxy was changing. The anomaly represented a force or structure whose expansion could one day influence the solar system itself. Humanity had time to study it, time to prepare, but only if it recognized the significance of what Voyager had uncovered. The universe was not static. It breathed, shifted, and evolved in ways that humans had only begun to perceive. Voyager 2, with its aging frame and persistent signal, had turned back not out of malfunction, but because it had brushed against something profound, something that demanded attention. The surge of global attention following Voyager 2's unexpected discovery created a wave of scientific urgency unlike anything in generations. As the implications began to unfold, the world realized that the probe had opened a door into a frontier far more complex than simple interstellar exploration. The anomaly was not an isolated curiosity. It was a signpost pointing toward a deeper structure in the galaxy, one that might influence the solar system's future in ways humanity had never considered. Researchers began to reinterpret decades of astronomical data through this new lens, searching for subtle hints that might have been overlooked. Patterns once dismissed as observational noise now appeared to carry significance. Distortions in cosmic background radiation, irregularities in the timing of pulsar emissions, and unexplained shifts in interstellar dust distribution were re-examined with a sense of urgency. Bit by bit, a picture emerged, not of chaos but of an order so vast and faint that only now, with Voyager's accidental encounter, could the pieces be fitted together. The first major revelation came from a team mapping historical interactions between the solar system and the wider galactic environment. They noticed a recurring trend. Every tens of millions of years, Earth had undergone dramatic shifts in climate, biodiversity, and atmospheric chemistry. While many of these events had natural terrestrial causes, the rhythmic timing hinted at influences beyond Earth's surface. Some had speculated for decades about the solar system's movement through varying densities of interstellar material, but the newly discovered interstellar structure added a new dimension. It was not simply that the sun passed through different regions of the galaxy, it was possible that these regions possessed dynamic properties capable of amplifying or altering cosmic energy flows. If the anomaly represented one such region, or even a boundary of a much larger field, its slow approach could one day intersect with the solar system in a way that shaped conditions on Earth. This possibility gave rise to an unprecedented collaboration among astrophysicists, geophysicists, and planetary scientists. Their simulations grew more sophisticated by the week, incorporating Voyager's data into models of galactic evolution. As they refined these models, a surprising hypothesis emerged. The anomaly's expansion did not appear random. Instead, it followed the galaxy's rotational currents with the slow inevitability of a tide moving along a shoreline. Over immense timescales, such structures could sweep across vast swaths of the galaxy, influencing star systems one by one. The solar system, it turned out, was positioned along a trajectory that the anomaly could eventually intercept. What this interception meant remained speculative, but early models suggested several possibilities. The least dramatic proposed that the heliosphere might compress, altering the flow of cosmic radiation into the solar system. Such a shift could affect atmospheric chemistry on Earth and potentially the climate. A more dramatic possibility involved the magnetic structure of the anomaly interacting directly with solar activity, inducing fluctuations in space weather that might challenge both technology and biological systems. The most extreme hypothesis suggested that the anomaly could act as a conduit, channeling energy or information in ways no physics currently understood. That idea remained at the fringe of scientific thought, but even its fringe status could not diminish the profound sense of mystery surrounding the anomaly's nature. As researchers explored the scientific dimensions, policymakers began grappling with the broader implications. Although the anomaly posed no immediate threat, its expansion raised questions about humanity's long-term preparedness. Should future space missions incorporate instruments capable of detecting similar structures? Should planetary defense strategies include planning for cosmic phenomena as well as asteroid impacts? Should humanity treat Voyager's discovery as a call to accelerate its understanding of interstellar space? These questions circulated through global councils and advisory boards, prompting a reevaluation of priorities. The notion that Earth was part of a dynamic galactic ecosystem, rather than a solitary world adrift in empty space, reshaped how future generations might view their place in the cosmos. Within academic circles, a new branch of study emerged: galactic environmental science. Previously, the environment of a planet was defined by its immediate surroundings, its atmosphere, geology, hydrology, and biosphere. But now, researchers argued that the environment extended far beyond the solar system's outer boundary, influenced by forces humanity had barely begun to grasp. This new discipline sought to understand how galactic-scale structures shaped the evolution of planetary systems, potentially influencing everything from climate cycles to the probability of life arising. Voyager's discovery had thrust humanity into a larger context, one where civilizations existed not simply as planetary inhabitants, but as participants in a vast cosmic interplay. Meanwhile, Voyager 2 continued transmitting data, revealing new layers of complexity within the anomaly. The patterns of fluctuation exhibited a kind of rhythm, not consistent like a heartbeat, but variable in a way that suggested multiple interacting cycles. Some cycles corresponded to cosmic ray flux, others to interstellar magnetic fields, and still others appeared linked to unknown parameters. These overlapping rhythms created interference patterns that resembled structures found in nonlinear systems, systems known for their ability to self-organize, adapt, and respond to external stimuli. The possibility that the anomaly might represent a form of emergent cosmic behavior grew increasingly plausible. This idea challenged philosophical frameworks. Many cultures had long conceived of the universe as a vast living system, but such ideas remained symbolic or spiritual. Now the notion gained scientific depth. If the galaxy contained regions that behaved like self-organizing fields, capable of responding to disturbances and evolving over time, then life might not be the only form of complex organization. The boundary between living and non-living systems blurred. The anomaly did not need to be conscious or deliberately designed to represent something profoundly intricate. Its patterns suggested that the cosmos might foster structures that functioned at scales too large and slow for human perception. Yet even as the anomaly's scientific significance unfolded, public fascination turned toward Voyager 2 itself. The probe became a symbol of humanity's resilience and ingenuity, a testament to engineering that defied the limits of time. No one had expected the aging craft to become the messenger of a discovery capable of reshaping humanity's understanding of the galaxy. Its unexpected turn and persistent transmission captured the imagination of millions. Schoolchildren learned its story as a reminder of the power of curiosity. Writers and filmmakers began to explore the philosophical dimensions of a universe filled with hidden structures. Voyager became a cultural beacon, standing at the intersection of science, art, and human identity. Scientists studying the probe's trajectory recognized something unexpected. The anomaly appeared to exert a subtle influence on Voyager's motion, one that did not align with known gravitational models. This influence was not forceful enough to pose danger, but it was detectable. Small deviations accumulated over time, hinting at forces that did not fit neatly into existing frameworks. Some researchers proposed that the anomaly contained gradients of energy density so faint they were undetectable through indirect observation, but noticeable when interacting with a small drifting object. Others speculated that the anomaly manipulated the motion of charged particles in a way that indirectly affected Voyager's trajectory. Whatever the explanation, the influence underscored how limited humanity's understanding of the interstellar medium remained. One of the most intriguing developments came from a group analyzing the anomaly's modulation cycles. They discovered that certain fluctuations aligned with long-term oscillations in the galaxy's magnetic field, oscillations spanning tens of thousands of years. This alignment suggested that the anomaly was sensitive to galactic-scale processes, responding to forces originating far beyond its immediate location. Such sensitivity implied that the anomaly might serve as a kind of cosmic indicator, revealing patterns normally invisible to local observation. By studying it, humanity gained a new vantage point on the galaxy's internal dynamics. At the same time, other scientists explored whether the anomaly could influence the formation or stability of planetary systems. If similar structures existed throughout the galaxy, and Voyager's encounter hinted that they did, then these fields could shape the distribution of matter during star formation. Regions that passed through an anomaly early in their evolution might develop differently from those that remained outside. This possibility ignited a wave of research into the distribution of exoplanets and the characteristics of stars in regions aligned with hypothetical anomaly pathways. If any correlation was found, it could reshape theories of planetary formation and habitability. The deeper humanity delved into Voyager's data, the more the anomaly seemed to intersect with questions about the probability and distribution of life in the galaxy. If the anomaly affected cosmic radiation levels or magnetic stability, it could have profound implications for where life was most likely to emerge. Planets shielded by such structures might experience lower radiation exposure, increasing the chances for complex organisms to evolve. Alternatively, worlds exposed to higher fluctuations might develop more rapidly or differently. The anomaly thus became not only a scientific mystery, but a clue in the ongoing search for extraterrestrial life. This connection prompted many to reconsider the Fermi paradox, the question of why, in a galaxy filled with stars and planets, humanity had not yet encountered evidence of other civilizations. If interstellar space contained dynamic structures capable of influencing technology or communication, then some regions might be effectively isolated. Civilizations separated by shifting cosmic fields might struggle to communicate across vast distances. Alternatively, advanced species might already understand these structures and use them for travel or communication in ways humanity could not yet imagine. Voyager's discovery added new dimensions to a question that had perplexed scientists and philosophers for generations. As new layers of understanding accumulated, awareness grew that the anomaly could serve as a gateway to breakthroughs in physics. Its structured fluctuations hinted at interactions between matter, energy, and space-time that eluded existing theory. Some researchers proposed that the anomaly might enable indirect observation of phenomena normally hidden within higher dimensional frameworks. Others suggested that it could represent a practical demonstration of principles predicted by theoretical models but never tested. Studying the anomaly might unlock insights into dark matter, quantum gravity, or the underlying architecture of space-time itself. All of this gave rise to a new narrative about humanity's future. Rather than viewing the galaxy as an empty expanse awaiting exploration, people began to see it as an environment rich with structure, history, and complexity. The solar system was no longer an isolated pocket, but part of a dynamic cosmic tapestry. Voyager 2, drifting through this tapestry, had brushed against a thread that revealed how interconnected everything truly was. This realization carried both promise and responsibility. If the universe was filled with hidden structures, then exploration required not only courage but wisdom. Humanity would need to understand the forces it encountered, not merely thrust itself blindly into the unknown. Even as these ideas matured, one question lingered above all others. Why had the anomaly responded to Voyager? Its fluctuations shifted in ways that reflected the probe's presence. Whether this response was active or passive remained unclear. It could have been a simple physical interaction, a system reacting automatically to a disturbance. Or it could have represented something deeper, a mechanism that detected motion across its boundary. If similar responses occurred when other objects passed through, then the anomaly might play a role in regulating the flow of matter or energy through interstellar space. Understanding this role would be essential before any future crewed missions ventured beyond the heliosphere. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what do you think Voyager 2 discovered and what major event do you expect next? We want to hear from you. Thank you for watching and see you next time.